Question number 1. Consider the expansion of 1 plus x to the power 2n plus 1. Question number 1 is, if the coefficients of x to the power r and x to the power r plus 1 are equal in the expansion, then r is equal to. So, general term in the expansion is t r plus 1 is equal to 2n plus 1 c r into x to the power r, and t r plus 2 is equal to 2n plus 1 c r plus 1 into x to the power r plus 1. Now, according to the question, 2n plus 1 cr is equal to 2n plus 1 cr plus 1. So, factorial 2n plus 1 upon factorial 2n plus 1 minus r into factorial r is equal to factorial 2n plus 1 upon factorial 2n plus 1 minus r minus 1 into factorial r plus 1. So we will be getting factorial 2n plus 1 upon factorial 2n plus 1 minus r into factorial r is equal to factorial 2n plus 1 upon factorial 2n minus r into r plus 1 into factorial r. So, factorial r cancels with factorial r and factorial 2n plus 1 cancels with factorial 2n plus 1. So, it will be 1 upon 2n plus 1 minus r into factorial 2n minus r is equal to 1 upon factorial 2n minus r into r plus 1. So, factorial 2n minus r cancels with factorial 2n minus r, and we will be getting 2n plus 1 minus r is equal to r plus 1. So, we will be getting 2r is equal to 2n. So, this will be r is equal to n. So, the answer is first option A. Now, come to the second part of the question. Second question. Now, second question is, the average of the coefficients of the two middle terms in the expansion is. So, number of terms in the expansion, this is equal to 2n plus 2 upon 2, 2n plus 1 plus 1 plus 1, that will be 2n plus 2, which is even. So, middle term are 2n plus 2 by 2, that is n plus 1, and n plus 2th term. So, tr plus 1, t n plus 1 will be 2n plus 1 cn x to the power n, and tn plus 2 that will be 2n plus 1 Cn plus 1 x to the power n plus 1. So the average will be 2n plus 1 Cn plus 2n plus 1 Cn plus 1 divided by 2. So if we place the values here, so the value is factorial 2n plus 1 divided by factorial n into 2n plus 1 minus n plus factorial 2n plus 1 divided by factorial n plus 1 into 2n plus 1 minus n minus 1 whole divided by 2. On solving, we will be getting 2 into factorial 2n plus 1 divided by factorial n into factorial n plus 1 into 2. That will be factorial 2n plus 1 divided by factorial n into factorial n plus 1, which will be 2n plus 1 Cn. So the answer is B. Now question number 3. Question number 3 is the sum of the coefficients of all the terms in the expansion is. We know that 1 plus x to the power 2n plus 1, this will be equal to 1 plus 2n plus 1 c1x plus 2n plus 1 c2x square plus and so on up to 2n plus 1 c2n plus 1 x to the power 2n plus 1. So put x is equal to 1 here. We will be getting 1 plus 1 to the power 2n plus 1 is equal to 1 plus 2n plus 1 c1 plus 2n plus 1 c2 plus up to 2n plus 1 c2n plus 1. So this will be 2 to the power 2n plus 1. That will be 2 to the power 1 into 2 to the power 2n. So this will be 2 into 4 to the power n. So 2 into 4 to the power n means the correct option is C. So the answer is C. Then comes question number 4. Now question number 4 is the nth term of an AP is 3 plus n by 4. So Tn is equal to 3 plus n by 4. Then the sum of the first 105 terms is. So T1 will be, on putting n is equal to 1, 3 plus 1 by 4 is equal to 4 by 4, which is equal to 1. T2 is equal to 3 plus 2 by 4, which is equal to 5 by 4. T3 is equal to 3 plus 3 by 4, which is 6 by 4, and so on. So common difference will be D is equal to 5 by 4 minus 1, that will be 1 by 4. So sum will be n by 2 bracket में 2a plus n minus 1 into d. So n will be 105 terms are there. So 105 upon 2 into first term is 1 plus n minus 1 means 105 minus 1 into d is 1 by 4. So this will be getting 105 by 2 into 2 plus 104 by 4. So this will be 105 upon 2 into 112 upon 4. That will be 105 into 14, that will be 1470. So the answer is B. Then comes question number 5. So question number 5 is, a polygon has 44 diagonals. The number of its sides are. So let the number of sides be n. So number of diagonals, that is equal to n into n minus 3 by 2. So the number of diagonals are n into n minus 3 by 2. This is given out to be 44. So 88 is equal to n square minus 3n. This implies that the n square minus 3n minus 88 is equal to 0. So this implies that n square minus 11x plus 8n, 11n plus 8n minus 88 is equal to 0. So this implies that n into n minus 11 plus 8 into n minus 11 is equal to 0. So n minus 11 into n plus 8 is equal to 0. This implies that n is equal to 11 since n cannot be equal to minus 8. Therefore, the answer is A. Then comes question number 6. Question number 6 is, if P, Q and R are in one geometric progression and A, B, C are in another geometric progression, then AP, BQ and CR are in. So first of all, P, Q and R, P, Q and R are in GP. So Q square is equal to PR, equation 1, and A, B and C are in GP. So B square is equal to AC, equation 2. Since AP, BQ and CR, so AP, BQ and CR are the given terms. So BQ square, that will be equal to B square Q square, that will be AC, put the value of B square and Q square, AC into PR, that will be AP into CR from 1 and 2, from equations 1 and 2. So this shows that, this implies that the AP, BQ and CR are also in GP. So answer is B. So the answer is B. Then comes question number 7. Question number 7 is consider a triangle ABC satisfying 2a sin square c by 2 plus 2c sin square a by 2 is equal to 2a plus 2c minus 3b. Question number 7. It is given 2a sin square c by 2 plus 2c sin square a by 2 is equal to 2a plus 2c minus 2b. Now we will put the values of sin square c by 2, sin square a by 2. We will be getting 2a into s minus a into s minus b divided by ab plus 2c into s minus b into s minus c upon bc. This will be equal to 2 times a cancels with a, 2 times s minus b into s minus a upon b plus c into c and c will be cancelled, so 2 times s minus b into s minus c divided by b. So this will be equal to 2 times s minus b and upon b is common, so it will be s minus a plus s minus c. This will be equal to 2 upon b into s minus b into b. So this will be equal to twice s minus b. That will be a minus b plus c. So this a minus b plus c will be equal to a minus b plus c. This will be equal to 2a plus 2c minus 3b. This implies that a plus c minus 2b is equal to 0. So 2b is equal to a plus c. This implies that the b is equal to a plus c by 2. And this implies that a, b and c are in AP. So the answer is B. Now comes question number 8. Question number 8. The question is, sin A, sin B and sin C are in, since A, B, C are in AP, therefore by sine law K sin A, K sin B and K sin C are also in AP. So dividing by K, sin A, sin B and sin C are also in AP. So the option is B. Then comes question number 9. Number 9. P is equal to tan of minus 11 pi upon 6. Q is equal to tan of 21 pi upon 4 and R is equal to cot of 283 pi upon 6. First of all, we will take tan P is equal to tan of minus 11 pi by 6. That will be tan of 2 pi minus 11 pi by 6. That will be tan of 6 is the LCM, 12 pi minus 11 pi by 6. That will be tan of pi by 6. That will be tan of 30 degree, which is equal to 1 upon root 3. Now comes the value of Q. Now Q is equal to tan of 21 pi by 4. That will be tan of 21 into 180 by 4. That will be tan of 21 into 45. That will be tan of 225. That will be tan of 180 plus 45. That will be tan of 45. That is 1. So Q comes out to be 1, and R is equal to cot of 48 pi minus 5 pi by 6. That will be equal to cot of minus 5 pi by 6. So this will be equal to cot of 2 pi minus 5 pi by 6. That will be cot of 7 pi by 6. That will be cot of pi plus pi by 6. That will be cot of pi by 6. That is root of 3. So the value of P into R, that is how much? 1. 1 upon root 3 into root 3, that will be 1. And P, Q and R are in P, Q and R are in GP. Since 1 is equal to, since 1 square is equal to 1 by root 3 into root 3. So P, Q and R comes out to be in GP, and P into R is 1. So the option is, first option is P into R का मान 2 है. इसका मतलब P into R is coming out to be 1 here, means this option is wrong. So the correct option is only 2, B. So the answer is B. केवल 2 सही है. Neither 1 nor 2 are correct. Then comes question number 10. Question number 10 is the number of ways in which 3 holiday tickets can be given to 20 employees of an organization. If each employee is eligible for any one or more of the tickets, then the number of ways are, out of the 20 employees, anyone can get a ticket. So number of ways are 20, and the number of holiday tickets can be repeated also. So another way is 20 and another way is 20. So the total number of ways are 8,000. So the correct option is D. Answer is D. Then comes 11th. Question number 11. What is the sum of n terms of the series root 2 plus root 8 plus root 18 plus root 32 and so on? So here, question number 11. The series is root 2 plus root 8 can be written as 4 2 root 2 and root 18 can be written as 3 root 2 and this is 4 root 2 plus and so on. So common difference D will be root 2. Root 2. So sum of the terms are n by 2, 2a, 2 into a. First term is root 2. So 2 into root 2 plus n minus 1 into d. D is again root 2. So we can say that it will be equal to n by 2. It is 2 root 2 plus root 2n minus root 2. So this will be n by 2 into root 2n root 2 plus root 2n. That will be n by 2, root 2 common, root 2n by 2 into 1 plus n. That will be n into n plus 1 upon root 2. So the correct option is C. ठीक है. Question number 12. The coefficients of x to the power 99 in the expansion of x minus 1, x minus 2, x minus 3 up to x minus 100 are, so coefficients of x to the power 99 in this are minus 1, minus 2, minus 3 up to this. So this will be minus 2a plus n minus 1 into d with n by 2. So minus 100 by 2 into 2 into 1 plus 100 minus 1 into 1. That will be minus 50 into 2 plus 99. That will be minus 50 into 101. That will be minus 50. So correct option is answer C. Now comes question number 13. Question number 13 is Question number 13 is z bar plus 3 minus I into z plus 3 plus I into z bar plus 1 is equal to 0. This represents a circle with center and radius. We have to find out. So let z is equal to a plus ib and z bar is equal to a minus ib. are two complex numbers. So Z A plus IB into A minus IB. This is Z bar plus 3 minus I into Z A plus IB plus 3 plus I into Z bar A minus IB plus 1 is equal to 0. So if we solve this, we will be getting A square plus B square plus 3A plus 3IB minus IA minus I square B plus 3A minus 3IB plus AI minus I square B plus 1 is equal to 0. So IA negative and IA positive will be cancelled, and 3IB positive and 3IB negative will be cancelled. So we get A square plus B square plus 6A plus 2B plus 1 is equal to 0. So A square plus B square plus 2 into 3A plus 2 into B plus 1 is equal to 0. Now compare this with x square plus y square plus 2gx plus 2fy plus c is equal to 0, that is with the standard equation of the circle. So we will be getting 2g So we will be getting 2g is equal to 6 and 2f is equal to 2 and c is equal to 1. So center of the circle will be minus g minus f. So this will be minus 3 and minus 1. And radius of the circle is equal to root of g square plus f square minus c. Now put the values of g, f and c. We will be getting minus 3 whole square plus minus 1 whole square and minus 1. That will be root of 9 plus 1 minus 1, that will be 3. So the correct option is option A. Center is minus 3 minus 1 and radius is 3. Now come on to the question 14. Now come on to the question number 14. Question number 14 is the number of 3-digit even numbers that can be formed from the digits 0, 1, 2, 3, 4 and 5. Repetition of the digits being not allowed is. So question number 14 is 3 digits numbers, and in the end if it is an even number, then in the end 0, 2 or 4 will come. So total number of ways of forming a 3-digit number is, unit place can be filled in 3 ways, either 0 or 2 or 4, 3 ways. And if one of 3 digits comes here, then in the tens place the total number of filling it is 5 ways, and similarly in the hundreds place 4 ways. So total number of ways are 4 into 5 into 3, that will be 60 ways. 60 ways. But here the number of those numbers will also come in which in the hundredth place 0 is there. So if we fix 0 in the hundredth place, and unit place can be filled in two ways, either 2 or 4, and 10th place will be filled by 4 ways, filled in 4 ways. Why? Because 0 is fixed here and one of the even number is fixed here. So out of the 6 numbers, 4 are left. So second, 10th place can be filled in 4 ways. So total number of ways, number of ways in which these numbers of 2 digits formed are 4 into 2, that will be 8 ways. So total number of ways of 3-digit numbers are 60 minus 8, that is 52 ways. So the correct option is C. Answer C. Then comes question number 15. Question number 15. Question number 15 is, if log 8 base m plus log 8 base 1 upon 6 is equal to 2 upon 3, then m is equal to, we have to find out. So this can be written as log of 8 base m into 1 upon 6 by log a base mn is equal to log a base m plus log a base n. This will be equal to 2 by 3. So by the definition of log, it is 8 to the power 2 by 3 is equal to m by 6. So this will be equal to 2 to the power 3 whole to the power 2 by 3 is equal to m by 6. So 3 cancels with 3. This will give you 2 to the power 2, that is 4 is equal to m by 6. So this will give you m is equal to 24. So answer is A. Correct option A. Correct option is A. Now come on to question number 16. Question number 16 is, question number 16 is, let capital X be the set of all persons living in Delhi. The person A and B in X are said to be related if the difference in their ages is at most 5 years. The relation is, which type of it is? It is reflexive, symmetric or transitive. This we have to find out. So for reflexive relation, A related to A. Since for reflexive, relation is reflexive, since for a person, difference between the age of a single person is 0. So A related to A holds, and relation is reflexive. It is symmetric because A related to B and B related to A. If the difference between the ages of A and B is 5 years, then the difference between the ages of B and A is also 5 years. So relation is symmetric. But A is related to B and B is related to C does not imply that A is related to C. Why? Because the difference between A and B is difference between the ages of A and B is 5 years. Difference between the ages of B and C is also 5 years, but the difference between the ages of A and C is 10 years, not 5 years. So it is not related, so it is not transitive. So it is not transitive. So the correct answer is D. reflexive and symmetric but not transitive. Now comes question number 17. Question number 17. The matrix A is equal to 1, 3, 2, 1, x minus 1, 1 and 2, 7, x minus 3. Will have inverse for every real number except 4. So this matrix A is invertible. Matrix A is invertible if determinant of A is not equal to 0. It is invertible if determinant of A is not equal to 0. So determinant of 1, 3, 2, 1, x minus 1, 1 and 2, 7, x minus 3. This is equal to, if we expand along the first column, so we will be getting 1, x minus 1, 1, 7 and x minus 3, minus 1 as 3, 2, 7 and x minus 3 and plus 2 as 3, 2, x minus 1 and 1. So this will be equal to, if we simplify this, we will be getting x minus 1 into x minus 3 minus 7 minus 3 into x minus 3 minus 14 plus 2 into 3 minus 2 into x minus 1 is equal to 0. And if we simplify it further, we will be getting x square minus 3x minus x plus 3 minus 7 minus 3x minus 9 minus 14 plus 6 minus 4 into x minus 1 is equal to 0. This will be x square minus 4x minus 4 minus 3x plus 23 plus 6 minus 4x plus 4 is equal to 0. 4 and 4 plus with minus cancelled, and we will be getting x square minus 11x plus 29 is equal to 0. So if we apply Sridharacharya formula, then we will be getting x square, then we will be getting x is equal to minus b plus minus root b square minus 4 into a into c whole divided by 2a. So it will be 11 plus minus root of 121 minus 116 divided by 2, which is equal to 11 plus minus root of 5 upon 2. So this value of x is not possible. So the answer is A. Then comes question number 18. Then comes question number 18. If the value of the determinant A 1 1 1 B 1 1 1 C is positive, this determinant is positive, greater than 0, where A is not equal to B, is not equal to C, then the value of ABC, we have to find out. So first of all, let us simplify this determinant. It will be A, B, 1, 1, C, minus 1, 1, 1, 1, C, plus 1, 1, B, 1, 1, determinant is greater than 0. Then comes A into BC minus 1 into C minus 1 plus 1 into 1 minus B is greater than 0. So ABC minus A minus C plus 1 minus B is greater than 0. So ABC minus common A plus B plus C plus 2 is greater than 0. So we will be saying ABC is greater than A plus B plus C minus 2. This is greater than, ABC is greater than A plus B plus C minus 2. So with the help of this, we can say that the value example. Now question number 19. Consider the following statements in respect of the determinant cos square alpha by 2, sin square alpha by 2, sin square beta by 2, cos square beta by 2, where alpha and beta are complementary angles. Then first option is the value of the determinant is 1 upon root 2 cos alpha minus beta by 2, and the second is the maximum value of the determinant is 1 upon root 2. So first of all, we will solve this determinant. Let the value of the determinant be capital A, then this will be equal to cos square alpha by 2 into cos square beta by 2 minus sin square alpha by 2 into sin square beta by 2. So this will be cos alpha by 2 cos beta by 2 whole square minus sin alpha by 2 sin beta by 2 whole square. So this will be equal to cos of alpha by 2 cos beta by 2 plus sin alpha by 2 sin beta by 2 into cos of alpha by 2 cos of beta by 2 minus sin alpha by 2 sin beta by 2. So this will be equal to cos of alpha by 2 minus beta by 2 into cos of alpha by 2 plus beta by 2, and this will be equal to half of 2 cos alpha by 2 minus beta by 2 into cos of alpha by 2 plus beta by 2. This will be equal to 1 by 2 cos alpha by 2 minus beta by 2 plus alpha by 2 plus beta by 2 plus cos of alpha by 2 minus beta by 2 minus alpha by 2 minus beta by 2. This is equal to half bracket में cos of alpha plus cos of beta this will be equal to 1 by 2. 2 cos alpha plus beta by 2 into cos of alpha minus beta by 2. This will be equal to cos of alpha plus beta by 2 into cos of alpha minus beta by 2. And since alpha and beta are complementary angles, therefore this is equal to cos of alpha plus 90 minus alpha by 2 into cos of alpha minus beta by 2. This will be equal to cos of 45 degree into cos of alpha minus beta by 2. And the value is cos of 45 degrees 1 by root 2 into cos of alpha minus beta by 2. So first option is correct. And for the second option, since cos theta has maximum value 1, therefore A max will be 1 by root 2. So the second option is also correct, and the correct answer is, which of the above statement is or are correct, means both 1 and 2. So answer will be C, both 1 and 2. Then comes question number 20. Then comes question number 20. Question number 20 is, what is 1, 2, 3, 4, 5, 6, 7, 8, 1 binary minus 0.0101 at the base 2 equals 2. So the correct answer is if we convert into decimals, then it will be from the right 1 into 2 to the power 9 plus 1 into 2 to the power 0, that will be 512 plus 1, that will be 530. So 0.0101 at binary, this will give you 0 into 2 to the power 0 plus 0 into 2 to the power minus 1 plus 1 into 2 to the power minus 2 plus 0 into 2 to the power minus 3 plus 1 into 2 to the power minus 4. That will give us 1 upon 4 plus 1 upon 16, that will be 5 upon 16, and that will be 0.3125. So numbers in decimals are 513.3125. When we subtract, we will be getting 512.6875. So the correct option is B. So answer is B. Now comes question number 21. Now comes question number 21. Question number 21 is, if A is equal to 1, 0, minus 2, 2, minus 3, 4, then the matrix capital X for which 2x plus 3a equals to 0 holds is true, given by, now you can see 2x will be equal to minus 3a and this will be equal to minus 3 into a will be this much, and 2x will be minus 3, 0, 6, minus 6, 9, minus 12. So x will be 1 upon 2 of minus 3, 0, 6, minus 6, 9, minus 12. So we can say that the x will be equal to minus 3 by 2, 0, 3, minus 3, 9 by 2 and minus 6. So the correct option is D. Now comes question number 22nd. Now question number 22nd is, here the correct option is D. Now question number 22nd is, if Z1 and Z2 are the complex numbers with Z1 mod is equal to Z2 mod, then which of the following is or are correct? So here we are given that question number 22 is, question number 22, Z1 mod is equal to Z2 mod. This is given to us. Let Z1 is equal to x1 plus iy1 and Z2 is equal to x2 plus iy2. So Z1 mod is equal to x1 square plus y1 square inside the root, and Z2 mod, this is equal to x2 square plus y2 square inside the root. Since Z1 mod is equal to Z2 mod, this implies that Z1 mod square is equal to Z2 mod square. So we can say that x1 square plus y1 square is equal to x2 square plus y2 square, which is only true when x1 is equal to x2 or y1 is equal to y2 separately. So the correct option is D, none. So answer will be D, because the first option is given us Z1 is equal to Z2, which cannot be true, and real part of Z1 is equal to real part of Z2, and imaginary part of Z1 is equal to imaginary part of Z2. Both will be equal separately. So answer will be D, which is none of the above. Then comes question number 23. Question number 23. Question number 23 is, if A is equal to 1, 1, minus 1, 2, minus 3, 4, and 3 minus 2, 3, and b is equal to minus 1 minus 2 minus 1, 6, 12, 6, and 5, 10, 5. Then which one of the following is or are correct? A and B commutes. So A into B is not equal to B into A. So the first option is wrong, and A into B we have to find out. So matrix 1, 1, minus 1, 2, minus 3, 4, 3, minus 2, 3. This multiplied with minus 1, minus 2, minus 1, 6, 12, 6, and 5, 10, 5. So we can say that A into B by row by column multiplication we will be getting minus 1 plus 6 minus 5 minus 2 plus 12 minus 10 and minus 1 plus 6 minus 5 minus 2 minus 18 plus 20 minus 4 minus 36 plus 40 and minus 2 minus 18 plus 20. So minus 3 minus 12 plus 50 minus 6 minus 24 plus 30 and minus 3 minus 12 plus 15. This much. So the value is 0, 0, 0, 0, 0, 0 and 0, 0, 0. So A into B comes out to be a null matrix. Therefore option 2 is correct. So answer is B, which is only 2. Then comes question number 25.
देखो मेरा बैच ऊपर से कहाँ गायब है? अच्छा मैं उधर से हूँ.
On to question number 24. One question is missed. 24. We have done 25 first. 24 is left. So question number 24. The number of real roots of the equation x squared minus 3 into x mod plus 2 is equal to 0. So it can be written as x mod square minus 3 into x mod plus 2 is equal to 0. That will be x mod square minus 2 into x mod minus x mod plus 2 is equal to 0. That will be, if we take x mod common, x mod minus 2 minus 1, x mod minus 2 is equal to 0. This we will get x mod minus 2 and x mod minus 1 is equal to 0. We will be getting x mod is equal to 2 or x mod is equal to 1. That will be x is equal to plus minus 2 and x will be equal to plus minus 1. So we get 4 roots out of this, the 4 values of x. So we can say that number of roots are 4. Answer is 4. The correct option is A. That's all. So question number 25. If the sum of the roots of the equation ax square plus bx plus c is equal to 0. If the sum of the roots of the equation this is equal to the sum of their squares, then four options are given. Let the roots be alpha and beta. Let the roots be alpha and beta. So according to the question, alpha plus beta is equal to alpha square plus beta square. So alpha plus beta is equal to alpha plus beta whole square minus 2 alpha beta. So minus b by a is equal to minus b by a whole square minus 2 into c by a. So we can say that minus b by a is equal to b square upon a square minus 2c by a. Multiplying the whole equation by a square, we will be getting minus ab is equal to b square minus 2ac. So this will be getting b square plus ab is equal to 2ac, which is option C. Now we move on to question number 26. If a is equal to x belongs to R such that x square plus 6x minus 7 is less than 0. This is the first step. And b is equal to x belongs to R such that x square plus 9x plus 14 is greater than 0. Then which of the following is or are correct? A intersection b is equal to open interval minus 2 to 1 and a minus b is minus 7 open to minus 2 open. So here first of all we will find out R. So a is equal to x belongs to R such that x square plus 6x minus 7 is less than 0. So x square plus 7 ones are 7, so 7x minus 7 is less than 0. So if you take x common, x plus 7, and if you take minus 1 common, x plus 7 is less than 0. So x plus 7 and x minus 1 is less than 0. If the product of two factors is less than 0, then we will make cases. Case 1, if x plus 7 is greater than 0 and x minus 1 is less than 0, then only their products will be less than 0. So x is greater than minus 7 and x is less than 1. So the interval comes out to be x is greater than minus 7 and less than 1. So here again case 2. Case 2 is x plus 7 is less than 0 and x minus 1 is greater than 0. This implies that x is less than minus 7 and x is greater than 1, which is absurd. So domain of definition, that is set A, has the points in the interval minus 7 to 1 open. Again, set B. Set B is x belongs to R such that x square plus 9x plus 40 is greater than 0. So x square plus 7 and 2 is 14. So 7x plus 2x plus 14 is greater than 0. Means if we take x common, then x plus 7 plus 2 common, x plus 7 is greater than 0. Or x plus 7 into x plus 2 is greater than 0. Again, the two cases arises. So, case 1, x plus 7 is greater than 0 and x plus 2 is also greater than 0. Positive into positive is positive. So, x is greater than minus 7 and x is greater than minus 2. So, this implies x is greater than minus 2. This implies x is greater than minus 2. And case 2 is x plus 7 is less than 0 and x plus 2 is also less than 0. So x is less than minus 7 and x is less than minus 2. This implies that the x is less than minus 7. So the set B is minus infinity to minus 7 open, union minus 2 to infinity open. So we calculated set A and B. Now we will find out A intersection B. So we will draw a line, real number line, 0 here, 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Now, the first interval, which is A, is minus 7 to 1 open. So this will be minus 7 to 1 open. And the second is minus infinity to minus 7. So minus infinity to minus 7, this one. And second one is from minus 2 to infinity, minus 2 to infinity. And here the intersection portion is minus 2 to 1. So A intersection B, this will give you minus 2 to 1 open. So A intersection B is minus 2 to 1. Again, we will find out A minus B. So A minus B will be A minus B. This will be, if we draw a line here and we draw A, means A is from minus 7 to 1. So it is A is from minus 7 to 1 and then up to minus 7. And then minus B. The set B is from minus 2 to plus infinity. Therefore, A minus B will be from minus 7 to minus 2. So, option A is correct and B is also correct. So, the correct answer is answer C, which is both 1 and 2. Now comes question number 27. Question number 27. Question number 27 is A, B, C and D are four sets such that A intersection B is equal to C intersection D is equal to 5. This means that if we draw Venn diagram, then this is set A, this is B, and A intersection B is 5, so A and B are disjoint. Again, C and D are also disjoint, but nothing can be said about A and C and B and D. So the first option is A union C and B union D are always disjoint. Nothing can be said about this because they may be joined also. So this option is wrong, and the second option is A intersection C and B intersection D, that is this portion. This is always disjoint. So this is correct, and option 2 is correct only. So the correct answer is B, which is 2 only. Now comes question number 28. Now question number 28. Question number 28 is, if A is an invertible matrix of order n and K is any positive real number, then the value of determinant Ka whole minus 1 into determinant of A means determinant K inverse into determinant of A. Its value is K to the power n. Its value is K to the power n. This is a theorem directly written. So now comes question number 29. The value of the infinite product 6 to the power 1 upon 2 into 6 to the power 1 upon 2 into 6 to the power 3 upon 8 into 6 to the power 1 upon 4 and so on. Now this is the question. So again, we can write this as 6 to the power 1 upon 2 into 6 to the power 3 upon 8 and so on into 6 to the power 1 upon 2 into 6 to the power 1 upon 4 and so on. So this is 6 to the power. Base is same, so the powers will be added up in multiplication. 1 by 2 plus 3 by 8 plus and so on. This into 6 to the power 1 by 2 plus 1 by 4 and so on. This will be 6 to the power. Now you see this is an infinite GP, so its R is 3 upon 4. So it is A upon 1 minus R into 6 to the power. This is again an infinite GP, so its A is 1 upon 2 and R is also 1 upon 2. So it is A upon 1 minus R. So this will be 6 to the power 1 upon 2 into 4 into 6 to the power 1 upon 2 into 2 upon 1. So this will be 6 to the power 1 upon 2 into 4 is 6 to the power 2 into 6 to the power 1, that is 6 to the power 3, which is 260. So the correct option is option number C. Answer is C. Now question number 30. If the roots of the equation x square minus nx plus m is equal to 0, x square minus nx plus m is equal to 0, differ by 1, then we have to find out the correct options. So let the roots be alpha and beta. So it is given that alpha minus beta is equal to 1. This is given to us. And again, from the equation we can find out sum of the roots, which is equal to minus b by a. So this will be equal to n, and alpha into beta is c by a, which is m. So from here we can find out alpha plus beta is n and alpha minus beta is 1. So from equation 1 and 2, from equation 1 and 2, alpha, if we add the equations, we will be getting 2 alpha is equal to 1 plus n, or alpha is equal to 1 plus n by 2. Now we will check the values here. For example, first option is n square minus 4n minus 1. Now we put the values here. We will be getting alpha plus beta whole square minus 4 alpha beta is equal to 1. So if we expand, we will get alpha square plus beta square plus 2 alpha beta minus 4 alpha beta is equal to 1. That will be alpha square plus beta square minus 2 alpha beta is equal to 1, or alpha minus beta whole square is equal to 1. So alpha minus beta comes out to be plus minus 1. So this option is correct. So answer is, correct option is A. Now comes question number 31. Question number 31. Question number 31 is, the area of the figure formed by the lines ax plus by plus c is equal to 0 and ax plus by minus c is equal to 0, ax minus by plus c is equal to 0, and ax minus by minus c is equal to 0. The area of the figure formed by these four lines we have to calculate. So here, this is first equation, this is second equation, third equation, fourth equation. So distance between the parallel lines 1 and 2. Distance between the parallel lines 1 and 2 is 2c upon root of a square plus b square, which is p1, and distance between parallel lines 3 and 4 is 2c upon root of a square plus b square, which is p2. Here P1 is equal to P2. Here P1 is equal to P2. So the figure is a rhombus. So it is a rhombus. Now comes area of the rhombus. So area of the rhombus we know that is equal to area of rhombus. This is equal to mod C1, that is C plus C, and C plus C divided by determinant A, B and A minus B. So this will be equal to 4C squared upon minus 2AB. That will be 2C squared upon AB. So the correct option is B. Correct option is B. Now comes question number 32. Now question number 32 is, if a line is perpendicular to the line 5x minus y is equal to 0 and forms a triangle of area 5 square units with the coordinate axes, then its equation is, you see the line perpendicular to 1 is, the line perpendicular to 1 is x plus 5y is equal to 0. And if it makes a area of 5 square units with the coordinate axes, then its equation will be x plus 5y plus minus 5 root 2 is equal to 0. So option A is correct. Then comes question number 33. Question number 33. Question number 33 is, consider any point P on the ellipse x square upon 25 plus y square upon 9 is equal to 1 in the first quadrant. Means if we plot this ellipse, we will be getting like this: 5 0 minus 5 0 0 3 and 0 minus 3. This is an ellipse. In the first quadrant, let R and S represents its distances from 4 0 and minus 4 0. This is the point 4 0, this is the point minus 4 0, and P is a point here. Its distance from 4 0 is R and from minus 4 0 is S. So R plus S is equal to 8. 4 plus 4, that is R plus S. So the correct option is answer C. Then comes question number 34. Question number 34 is, a straight line question number 34, a straight line x is equal to y plus 2 touches the circle. This is the equation of the line, and equation of the circle is 4 into x square plus y square is equal to r square. So it will be x square plus y square is equal to r square by 4. That is, x square plus y square is equal to r by 2 whole square. So this is the second equation. Now we have to find out the value of r. So if a line touches a circle, then from the center of the circle, if we draw a perpendicular, then that perpendicular will be equal to the radius. So its center of the circle is 0, 0, and if from 0, 0 we draw a perpendicular onto this line, we will be getting 0 minus 0 minus 2 divided by root of 1 square plus 1 square is equal to the radius r by 2. So this will be equal to 2 upon root 2 is equal to r upon 2. That implies r is equal to 2 root 2. So the correct option is B. So the correct option is B. Now comes question number 35. Question number 35. It has been given that the three lines 4x plus 4y is equal to 1. This is the first line. Then 8x minus 3y is equal to 2. This is the second equation. And y is equal to 0. This is the third equation. So if we plot these three lines on a Cartesian plane, then we will be getting 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So if we plot the line, that is 4x plus 4y is equal to 1, we will be getting this line, 4x plus 4y plus 1 is plus minus 1 is equal to 0. And second line will be like this. This is the point 1, 4 by 4, 0, and this is the point 0 minus 2 by 3, and the third is the equation of the line y is equal to 0, means x is of x. So the three lines are passing through one point, therefore the lines are concurrent. So the correct option is B. The lines are concurrent. 36. The line 3x plus 4y minus 24 is equal to 0 intersects the x-axis at A and y-axis at B. So if we plot the line on the axis of x and axis of y, so first of all we put x is equal to 0, then we get 0 plus 4y minus 24 is equal to 0. This will give you y is equal to 6. So the point is 0, 6, and 0, 6 is here, 0, 6. This is a point on the y-axis, so it is the point B. And again, for the x-axis, put y is equal to 0, means 3x minus 24 is equal to 0. So x is equal to 8. So the point is on the x-axis, it is 8, 0. So 1, 2, 3, 4, 5, 6, 7, 8. This is the point 8, 0, and this is 8. So the line is this. This is the line 3x plus 4y minus 24 is equal to 0. Now he is asking, then the circumcenter of the triangle OAB, where O is the origin. So if we find out a circumcircle, then that circle has AB as the diameter. So its center center C will be the midpoint of AB, that is 4, 3. So the correct option is answer C. Then comes question number 37. Question number 37. The eccentricity of the hyperbola 16x square minus 9y square is equal to 1. This can be written as, in the standard form, x squared upon 1 by 16 minus y squared upon 1 by 9 is equal to 1. And if you compare this with the standard form, x squared upon a square minus y squared upon b square is equal to 1, we will be getting a is equal to 1 upon 4 and b is equal to 1 upon 3. Then we have to find out the eccentricity of the hyperbola. So b square is equal to a square bracket e square minus 1. Now we put the values of b square. It is 1 by 9 is equal to a square 1 by 16 into e square minus 1. So e square minus 1 is equal to 16 upon 9. So we can see that e square is equal to 1 plus 16 upon 9. So e square is equal to 9 plus 16. So e square is equal to 25 by 9. So e will be 5 by 3. So the correct answer is, the correct option is B. So the answer is B. Now we move on to question number 38. Question number 38. 38th question is the product of, question number 38 is the product of perpendiculars from the 2 points plus minus 4, 0 onto the line 3x cos of phi plus 5y sine of phi is equal to 15. This is the equation of the line. So first of all, we find out the length of the perpendicular from the point plus 40 onto this line. That will be 3 into 4 into cos of phi plus 5 into 0 into sine of phi minus 15 divided by root of 3 cos phi its whole square plus 5 sine phi its whole square. So we will be getting this is equal to 12 cos phi minus 15 divided by root of 9 cos square phi plus 25 sine square phi. That will be equal to P1 is equal to 12 cos phi minus 15 divided by root of, this will be written as, cos square phi will be written as 1 minus sine square phi plus 25 sine square phi. That will be 12 cos phi minus 50 upon root of 9 plus 16 sine square phi. So this is your P1. Now come on to P2. Now P2 is 3 cos phi into minus 4 plus 5 sin phi into 0 minus 15 divided by root of 3 cos phi whole square plus 5 sin phi whole square. This will be equal to minus 12 cos phi minus 15 divided by root of 9 cos square phi plus 25 sin square phi. This is equal to 12 cos phi plus 15 divided by root of 9 minus plus 9 plus 16 sine square phi. So we get P1 and P2, and according to the question, the product of the perpendiculars we have to find out. So product of the perpendicular P1 and P2, this will be, if we multiply them, we will be getting 81 plus 144 sine square phi divided by 9 plus 16 sine square phi. That will be equal to, if we take 9 common, we will be getting 9 plus 16 sine square phi divided by 9 plus 16 sine square phi. That is, this whole cancels with this and we will be getting 9. So the correct option is option C. So the answer is C. Answer is C. Then comes question number 39. Question number 39 is, if the center of the circle passes through the origin is 3, 4. Let this be the origin, and a circle passing through the center has center 3, 4. 3, 4. This is the origin, so 0, 0. In this way, we can find out the radius of the circle. For example, the radius will be 3, 4, and distance between 3, 4 and 0, 0. That will be 3 minus 0 ka whole square plus 4 minus 0 square, that is 9 plus 16, that is root 25, that will be 5. So radius is 5, and they intercept cut off by the circle on the x and y axes respectively. We have to find out, means we have to find out OA and OB. And for OA, if we draw a perpendicular from C onto this, that is D, then OD will be equal to 3. And according to the theorem, from the center, if the perpendicular is drawn on a chord, then that will bisect the chord. Means this is 3, so this will be 3. So OA will be 6. And similarly, if we draw a perpendicular from C onto OB, then this OA distance is equal to CD distance, which is equal to 4. So this is 4 and this is also 4. So OB comes out to be 8. Therefore, intercept cut on the x-axis is 6 and intercept cut on the y-axis is 8. So the correct option is 6 units and 8 units, that is D. Then comes question number 40. Then comes question number 40. Question number 40 is the lines 2x is equal to 3y is equal to minus z and 6x is equal to minus y is equal to minus 4z. These are the two lines. We have to tell that whether they are perpendicular, parallel, intersect at an angle 45 degree or intersect at an angle 60 degree. So first of all, we write down the Cartesian equations of the line. This is y upon 1 by 3, which is z upon minus 1. And the equation of this line is x upon 1 by 6 is equal to y upon minus 1 is equal to z upon minus 1 by 4. So it is multiplied by the LCM, that is x by 3 is equal to y by 2 is equal to z by minus 6, and the line is x upon 2 y upon minus 12 is equal to z upon minus 3. So these are the direction ratios of the line. So A1 into A2 plus B1 into B2 plus C1 into C2 is equal to 0 for lines to be perpendicular. Therefore, this implies 3 into 2 plus 2 into minus 12 plus minus 6 into minus 3. That is equal to 6 minus 24 plus 18, which is equal to 24 minus 24, which is equal to 0. So the lines are perpendicular and the correct option is A. Then comes question number 41. Question number 41. Two straight lines passing through the point A, 3, 2 cuts the lines 2y is equal to x plus 3 and x-axis perpendicularly at P and Q respectively. Then the equation of the line PQ is. So first of all, we will find out y is equal to x plus 3 is the given line. So its slope is m is equal to minus 1 upon minus 2. That is minus coefficient of x but by coefficient of y, which is equal to 1 upon 2. So slope of the perpendicular line, that will be equal to minus 2. Now equation of the line passing through A, 3, 2 and having slope minus 2 is given by y minus 2 is equal to minus 2 into x minus 3. This is from y minus y1 is equal to n times x minus x1. So y minus 2 is equal to minus 2x plus 6. So 2x plus y minus 8 is equal to 0 is the required line. So the correct option is C. Answer C. Then comes question number 42. Then comes question number 42. The radius of the sphere 3x square plus 3y square plus 3z square minus 8x plus 4y plus 8z minus 15 is equal to 0. We have to find out the radius of this sphere. So here, first of all, we make the coefficients of x square, y square and z squares unity. So divide by 3, we will be getting x square plus y square plus z square minus 8 by 3 into x plus 4 by 3 into y plus 8 by 3 into z minus 5 is equal to 0. Now the radius will be, first of all, if we compare, then radius will be root of g square plus f square plus h square minus c. That will be root of, this is minus 8 by 6, that is minus 8 by 6 whole square plus 4 by 6 whole square plus 8 by 6 whole square minus 5, that will be 5. So it will be root of, this is 64 by 36 plus 16 by 36 plus 64 by 36 plus 5. That will be equal to root of 324 by 36. So it will come out to be root of 9, which is equal to 3. So the correct answer is B. So radius of the sphere comes out to be 3. Then comes question number 43. Question number 43 is, question number 43, it is the direction ratios of the line perpendicular to the lines with the direction ratios of line 1 is 1 minus 2 and minus 2, and direction ratios of line 2, that is 0 to 1. We have to find out the direction ratios of the line perpendicular to both the lines with the following direction ratios. So first of all, we will be getting, let the direction ratios of the required line be A, B and C. Therefore, by the perpendicularly condition, that is A minus 2B minus 2C will be equal to 0, since the required line is perpendicular to the first line. Therefore, A1 A2 plus B1 B2 plus C1 C2 is equal to 0, and A into 0 plus 2B plus C is equal to 0. This is the first equation, this is the second equation. Solving 1 and 2, we will be getting A is equal to C. So the option is 2 minus 1 2 is correct. in which only A is equal to C. So the correct option is option A. Number 44. What are the coordinates of the foot of the perpendicular drawn from the point 354 on the plane Z is equal to 0? Z is equal to 0 means, this implies XY plane, means the foot of the perpendicular lies in the XY plane. So it has coordinates XY, 0. So foot of the perpendicular will be is 3, 5 and 0. So the correct option is B. Now comes question number 45. Now question number 45 is, the length of the intercepts on the coordinate axes made by the plane 5x plus 2y plus z minus 13 is equal to 0. Now this can be written as 5x plus 2y plus z is equal to 13. If we divide by 30, then we will be getting 5x by 30 plus 2y by 30 plus z by 30 equals to 1. Now this can be written as x upon 13 upon 5 plus y upon 13 upon 2 plus z upon 30 is equal to 1. So in the intercept form, if we compare this with x upon a plus y upon b plus z upon c equals to 1, we will be getting a is equal to 13 upon 5, b is equal to 13 upon 2 and c is equal to 13. So the correct option is B. So the answer is B. Then comes question number 46. Question number 46. If different words are formed with the letters of the word again, the word is again. If different words are formed with the letters of the word again and arranged alphabetically among themselves as in a dictionary, then the word at the 58th place, we have to find out the word at the 58th place in dictionary. So first of all, we will find out total number of words, total words formed by this word. So this is equal to factorial 5 upon 2. So factorial 5 upon factorial 2 means 5 into 4 into 3 upon 1. That is 5 4s are 20 and 3 is 60. So 60 words will be formed. Now we have to find out the word at the 58th place. So first word will be like this. If we make column and we fix A here, if we fix A, then factorial 4 words will be formed here. That is, total number of words are 24. Then again we fix G here and total number of words forms are factorial 4 by factorial 2, that will be 12 words. If we fix I here, then again total number of words are 12 words. Then 24 plus 24, that is 48 words are formed. Then again the next word will be, if we take N here, then the word form will be NA according to the dictionary, NA into NA GR, and this will be the 49th word, and the last is NA A A I G. This is the 50th word. So the correct option is B. So the correct option is B. Then comes question number 47. Then comes question number 47. The number of ways in which a cricket team of 11 players chosen out of a batch of 15 players so that the captain of the team is always included. So, question number 47. Captain of the team is always included. So, out of the 14, we have to choose 10. That is factorial 14 upon factorial 10 into factorial 14 minus 10. That will be factorial 14 upon factorial 10 into factorial 4. That is 14 into 13 into 12 into 11 divided by 4 into 3 into 2. And if we solve this, we will be getting 91 into 11, which is 1001. So the correct option is C. So the correct option is C. Then comes question number 48. Question number 48. In the expansion of root of x plus 1 upon 3x square whole to the power 10, the value of the constant term, means independent of x, is, we have to find out. So first of all, we will find out the general term. So tr plus 1 is equal to 10 cr into root x to the power 10 minus r into 1 upon 3x square whole to the power r. If we simplify this, then we will be getting 10 cr into x to the power 10 minus r upon 2 into 1 to the power r divided by 3 to the power r and x to the power 2r. So this will be equal to 10 cr into x to the power 10 minus r upon 2 minus 2r into 1 to the power r upon 3 to the power r. So for term independent of x, the power of x should be equal to 0. So 10 minus r upon 2 minus 2r should be equal to 0. If we simplify this, we will be getting 10 minus r upon 2 is equal to 2r. So 10 minus r is equal to 4r. So 5r is equal to 10. So r is equal to 2. So 10c 2 into 1 to the power 2 upon 3 to the power 2 means this is the coefficient, factorial 10 upon factorial 2 into factorial 8 into 1 upon 9. If we simplify this, we will be getting 5. So the correct option is A. Then comes question number 49. Question number 49 is the value of sine square 5 degree plus sine square 10 degree plus sine square 15 degree plus and so on up to sine square 90 degree. So if we find out how many terms are there, so 5 plus 10 plus 15 up to 90, and if we apply number of terms, then it will be equal to a plus n minus 1 into d, and this is the last term, that will be 90. So 5 plus n minus 1 into d is 5 is equal to 90. This will be given 90 is equal to 5 plus 5n minus 5. So n will be equal to 90 upon 5, that is 18. So 18 terms are there, and if 18 terms are there, then out of the 18 terms, we take 17 terms, sine square 5 degree with sine square 85. Then this can be written as sine square 5 plus sine square 5, that is sine square 90 minus 5, that is sine square 5 plus cos square 5, which is equal to 1. So if we take first term and the second last term, we will be getting 1 here. So out of the 18 terms, half of the terms summation is there, so number of terms are 9. So the correct option is 9, which is C. Option C is correct. Then comes question number 50. Question number 50 is, on simplifying sine cube A plus sine 3A upon sine A plus cos cube A minus cos 3A upon cos of A. We have to simplify this. So first of all, we know that sine of 3a is equal to 3 sine a minus 4 sine cube a. So sine cube a will be equal to, sine 3a will be equal to 3 sine a minus 4 sine cube a plus sine cube a divided by sine a. We place the value of sine 3a here plus cos cube a minus 4 cos cube a minus 3 cos a divided by cos a. So if we simplify this, we will be getting 3 sine a minus 3 sine cube a upon sine a plus 3 cos a minus 3 cos cube a upon cos of a. If we take 3 sine a common, what we will get? 1 minus sine square a upon sine of a plus, if we take 3 cos a common here, 1 minus cos square a upon cos of a. If we simplify further, then sin a cancels with sin a and cos a cancels with cos a. So we will be getting 3 cos square a plus 3 sin square a. And if we take 3 common, sin square a plus cos square a equals to 1. So 3 into 1 means 3. So the correct option is D. Correct option is D here. Then comes question number 51. Then comes question number 51. It is, find the value of tan of 2 tan inverse 1 upon 5 minus pi by 4. We have to find the value of this term. So this will be tan of, now we know that 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square minus pi by 4. So this is equal to tan of tan inverse 2 by 5 upon 1 minus 1 by 25 minus pi by 4. So this is equal to tan of tan inverse 2 by 5 into 25 by 24. So this is tan inverse 5 by 12. Now this is tan of tan inverse 5 by 12 minus pi by 4. Now we apply the formula of tan of A minus B. So that will be tan of A minus tan of B divided by 1 plus tan A tan B. So this will be tan of tan inverse 5 by 12 minus tan of pi by 4 divided by 1 plus tan of tan inverse 5 by 12 into tan of pi by 4. So this will be equal to 5 by 12 minus 1 upon 1 plus 5 by 12 into 1. That will be equal to 5 minus 12 upon 12 plus 5, that is minus 7 upon 17. So the correct option is A. So the correct option is A. Then comes question number 52. Question number 52. Question number 52 is, two poles are 10 meter and 20 meter high. So if we draw two poles 10 meter and 20 meter. So two poles are 10 meter and 20 meter high. The line joining their tops makes an angle of 15 degree with the horizontal. Line joining their tops A, B, C, D, then AC line makes an angle of 15 degree with the horizontal. So find out the distance between the poles is approximately equal to. We have to find out AE. So let us assume that A is equal to X. And then we find out X. So in triangle ACE, tan of 15 degree is equal to 10 upon X. So tan of 15 degree can be written as tan of 45 degree minus 30 degree is equal to 10 upon X. So tan 45 minus tan 30 upon 1 plus tan 45 tan 30 is equal to 10 upon X. So this will be 1 minus 1 by root 3 upon 1 plus 1 by root 3 is equal to 10 upon X. So if we simplify further, then we will be getting root 3 minus 1 upon root 3 plus 1 is equal to 10 upon X. So X will be equal to 10 into root 3 plus 1 upon root 3 minus 1. If we simplify it further, then this will be 10 into root 3 plus 1 whole square divided by 2. So this will be 5 into 3 plus 1 plus 2 root 3. And if we simplify it further, that will be 10 into 2 plus root 3, which is equal to 37.32. So the correct option is B. Now we come on to question number 53. Question number 53 is, if gx is equal to 1 upon fx, gx is equal to 1 upon fx, and fx is equal to x, and fx is equal to x, then which one of the following options is correct? So we will check the first option, f of g of fx. That will be f of g of fx, and fx is equal to what? X. So it will become gx. So this will be f of g of gx. So it will become g of gx is equal to 1 upon fx. So it is 1 upon fx, and this will be f of g of 1 upon x. That is f of 1 upon x. That will be f of x. That will be f of x. That will be f of x, which is equal to x. So we find out that f of g of fx is equal to x. Then we will find out the right hand side, which is g of fx. That will be equal to g of f of gx, and that will be equal to g of f of 1 upon fx. That is equal to g of f of 1 upon x. That is equal to g of f of x. That is g of x. That is g of 1 upon fx. That is g of 1 upon x. That is 1 upon f of 1 upon x. That is 1 upon x. That is x. So the correct option is A. First option is correct. So this is A. Then comes question number 54. Then comes question number 54. Consider the following: sine inverse 4 by 5 plus sine inverse 4 by 5 plus sine inverse 3 by 5 is equal to pi by 2. And the second option is tan inverse root 3 plus tan inverse 1 is equal to minus tan inverse 2 plus root 3. Which of the above is or are correct? Options are given. So take 54. Let sine inverse 3 by 5 is equal to theta. That is, sine of theta is equal to 3 by 5. If we draw a triangle with theta Sine theta is 3 by 5. So perpendicular upon hypo. This will give you 4 here. So cos of theta is equal to 4 by 5. So theta is equal to cos inverse 4 by 5. So in place of sine inverse 3 by 5, we can write cos inverse 4 by 5. Therefore, the above expression becomes sine inverse 4 by 5 plus cos inverse 4 by 5 is equal to what? Pi by 2. So the first option is correct, means first option is correct. Then comes second one. Second one is tan inverse root 3 plus tan inverse 1. This is equal to minus tan inverse 2 plus root 3. This we have to check out. So tan inverse root 3 plus tan inverse 1 can be written as tan inverse root 3 plus 1 upon 1 minus root 3. This will be equal to tan inverse 1 plus root 3 into 1 minus root 3 divided by 1 minus 3, which is equal to tan inverse 1 plus 3 plus 2 root 3 divided by minus 2. So this will be tan inverse 2 plus root 3 upon minus 1, which is minus tan inverse 2 plus root 3. So the second option is also correct. So the correct option is both 1 and 2 is correct, are correct, means answer is C. Then comes question number 55. Then comes question number 55. If A is an orthogonal matrix of order 3 and B is equal to 1, 2, 3, minus 3, 0, 2, 2, 5, 0. If B is this matrix, then which one of the following is or are correct? So first of all, we find out AB determinant is equal to plus minus 47. That means that B into I upon A transpose mod is equal to plus minus 47. That is B determinant into I upon A transpose is equal to 40 plus minus 47. So 47, if we find out B determinant, then B determinant comes out to be minus 47. So 47 mod into I upon A transpose is equal to 47. So this cancels with this and A transpose comes out to be I. It means that I is equal to 1 0 0 0 1 0 0 0 1 is equal to A transpose. So A will be 1 0 0 0 1 0 0 0 1, and similarly AB determinant is equal to BA determinant. So we say that both the options are correct here. So the correct option is option C, both 1 and 2. Then comes question number 56. Question number 56 is, if A, B and C are the sides of the triangle, then A to the power 1 upon P plus B to the power 1 upon P plus minus C to the power 1 upon P, where P is greater than 0 or P is greater than, I think so it is 1, is greater than 1, then this expression is always negative, always positive, always 0, or the fourth one is positive if p is greater than 1, less than 2, and negative if p is greater than 2. So let us take p is equal to 2. Then a to the power 1 upon 2 plus p to the power 1 upon 2 minus c to the power 1 upon 2. Now the sum of the two sides of the triangle is always greater than the third side. So we say that a to the power 1 upon p plus p to the power 1 upon p minus c to the power 1 upon p is always greater than 0. So it is always positive. It is always positive. So the correct option is option B. So the correct option is B. Now we come on to the question 57. Question number 57. If A, B, C are real numbers, then the value of the determinant 1 minus A, 1 minus B, 1 minus C, A minus B minus C, B minus C minus A, C minus A minus B, B plus C, C plus A plus B determinant. And the value of this determinant is, if we find out, then it is, first of all we apply C1 in place of C2, we put C2 plus C3. That is 1 minus A, 1 minus B, 1 minus C. That is A, B, C, and B plus C, C plus A plus B. Now again we apply C1 in place of C1. We apply C1 plus C2. So we will be getting 1, 1, 1, A, B, C, B plus C, C plus A plus B. Now again apply in place of C2, C2 plus C3. So we will be getting 1, 1, 1, A plus B plus C, A plus B plus C, A plus B plus C, B plus C, C plus A, and A plus B. That will be, if we take A plus B plus C common, then 1, 1, 1, 1, 1, 1, and B plus C, C plus A plus B. That is, the value of the determinant comes out to be 0. So the correct option is option A. The correct option is option A. Then comes question number 58. Then comes question number 58. Question number 58 is, if the point Z1 is equal to 1 plus I, where I is equal to root of minus 1, the reflection of the point Z2 is the reflection of the point Z2, which is equal to x plus iy in the line iz bar minus iz is equal to 5. Then the point Z2 is, we have to find out the point Z2. We have to find out the point Z2 here. So first of all, solve Z1. So first of all, solve let I into x minus iy minus I into x plus iy is equal to 5. If we simplify this, we will be getting ix minus I square y minus ix minus I square y is equal to 5. And ix and ix will be cancelled. So minus I square means plus 1. So y plus y is equal to 5. So 2y is equal to 5 means y is equal to 5 by 2. This means that the line is a line which is parallel to the x-axis at a distance of 5 upon 2. And the point is z1 is 1 plus I, means the point is somewhere here 1 plus I, that is 1 comma 1. This is your z1 and its image in this line L is at the distance equal to which the z1 is placed in front of the line L. So this is 1 1, this distance is 1, so this total distance is 5 by 2, so this distance is 3 by 2. So this distance is also 3 by 2 and this is the point 4 comma 1. So the point is 4 plus I. So the correct option is 4 plus I, that is B. Correct option is B. Or the correct option is 1 comma 4. The correct option is 1 comma 4. So the correct option is 1 plus 4i, that is A. Then comes question number 59. Then comes question number 59. Is sin x plus sin y is equal to A and cos of x plus cos y is equal to B. Then we have to find out the value of tan square x plus y by 2 plus tan square x minus y by 2 is equal to what? This we have to find out. So first of all, we find out the value of sine of x minus y by 2. So we can find out sine of x into sine of y plus cos of x into cos of y is equal to a square plus b square minus 2. So 2 plus 2 into cos of x minus y is equal to a square plus b square. So 2 plus, that is 4 cos square x minus y by 2 is equal to a square plus b square. So cos square x minus y by 2 is equal to a square plus b square by 4. This is your equation 1. And 2 plus 2 into 1 minus 2 sine square x minus y by 2 is equal to a square plus b square. So 4 minus 4 sine square x minus y by 2 is equal to a square plus b square. So we can say that sine square sine square x minus y by 2, this is equal to 4 minus a square plus b square by 4. And again we find out 2 into sine of x plus y by 2 into cos of x minus y by 2 upon 2 into cos of x plus y by 2 into cos of x minus y by 2 is equal to a upon b. So cos x minus y by 2 and 2 and 2 will cancel. Tan of x plus y by 2 is equal to a upon b. So tan square x plus y upon 2 is equal to a square upon b square. Second equation. So if we place the values of tan square x by 2 and tan square x plus y by 2 in the given expression, we will be getting tan square, that is tan square x plus y by 2 is a square upon b square plus 4 minus a square minus b square upon a square plus b square. That will be a to the power 4 plus a square b square plus 4b square minus a square b square minus b to the power 4 when we take a square plus b square and b square as LCM. Then a square b square cancels with a square b square and the result is 4 minus a square. The result is a to the power 4 plus 4b square minus b to the power 4 upon a square b square plus b to the power 4. So the correct option is B. So the correct option is B. Then comes question number 60. Question number 60. Now, in question number 60, a vertical tower is standing on a level field is mounted with a vertical flagstaff of length 3 meters. Means if we draw the figure, we see here, this is the vertical tower of height h and a flag stuff is here of 3 meter height is placed and the angle of elevation is 30 degree of the bottom of the flagstaff and 45 degree of the top of the flagstaff. Let the distance AB be x. Then we have to find out which of the following gives the best approximation to the height of the tower. Means we have to find out the height of the tower. So first of all, in triangle A, B, C, tan of 45 degree, this is equal to h plus 3 upon x. That is 1 is equal to h plus 3 upon x. So we can say that x is equal to h plus 3. So this is the first equation. And in triangle A, B, D, tan of 30 degree is equal to h upon x. So 1 upon root 3 is equal to h upon x. Means h is equal to 1 upon root 3 is equal to, with the help of first equation, we can write h upon h plus 3. So if we simplify, we will be getting root 3h is equal to h plus 3, or root 3h minus h is equal to 3, or if we take h common, root 3 minus 1 is equal to 3. This gives us h is equal to 3 upon root 3 minus 1. And if we rationalize this, we will be getting root 3 into root 3 plus 1 upon root 3 minus 1 into root 3 plus 1. That means 3 into root 3 plus 1 divided by 3 minus 1, which is 3 into root 3 plus 1 divided by 2. If we simplify this, we further get 3 into 1.732 plus 1 divided by 2. So 3 into 2.732 by 2 means 3 to the 6, 3 to the 9, 3 7 the 21, 3 to the 6 and 2 8. 8.196 by 2, which is 4.098. This implies that the correct option is 4.1. That is option C.